Okay, so we're going to do this question. What we're told is a probability density function of a lifetime of an electrical device given by this expression here. We have to find the cumulative density function and sketch it. We've got to find the probability that x is greater than 15 and find the probability that 6 of these devices, 3 of them will function at least 15 hours. We're also going to calculate the expectation and the variance, and we're also going to check that this is indeed a distribution. So let's just set ourselves up. F of x equals 10 on x squared, x greater than or equal to 10. The equality here doesn't actually matter because it's a continuous distribution and equality contributes nothing to the probabilities because we're integrating. So this is our PDF, right? So we want to get from the PDF to a CDF, right? And a CDF is the indefinite integral. So you might write that like this. So you're integrating from negative infinity up to some variable x, which means we need a dummy variable in our integral. So we're going to change that to a t, right? So we're putting this in here. But also we've got to account for the fact that this is piecewise. So I've got to also account for the possibility that it's 0 given these two conditions, right? So what we're going to do now is, condition 1, condition 2. What we're going to do is we're going to just change the bottom limit to x greater. So it's we're not integrating from negative infinity to 10 anymore, right? Because that contributes nothing to the probability. We just go from 10 to x, 10 t squared dt. All right. So we can go ahead and do this integral. It's very straightforward. You just add 1 to the power, divide by the new power. So we're adding 1 to negative 2, so we get negative 1. So that goes to minus 10 on t, evaluated between 10 and x. So that is minus 10 over x minus 10 on 10, which is 1. So that's equal to 1 minus 10 over x. Now let's check that this is indeed a distribution. That is, that it integrates to 1 over the whole real line. So we can check that easily. We've already done the integral from negative infinity to 10 because that's 0. Now we've just got to check that as x tends to infinity in this expression, that this limit tends to 1. So that's equivalent to asking, which is indeed 1 because this 10 over x will disappear as x tends to infinity. Right? So this is our CDF. This is checking that it's a distribution, right? Now we've got to plot our CDF. So what we have is we know that we got something happening at x equals 10. That's where we go from 0 to this kind of behavior. Right, and the CDF is obviously 0 before that, right? So what does this look like? Well, at x equals 10, we've got 0. And as x gets bigger, right, this tends to 1, right? So we know that in our limit out here somewhere, we're going to be tending towards a value of 1. So let's just draw this in as an asymptote. We also know that we've got something that looks like this, right? This is, say, 10 over x, as x is varying. So if we subtract that from 1, right, what we're going to see is we're going to see this kind of difference. So what we're actually going to be doing is kind of plotting this thing upside down, as when x is 10, obviously it's 0. When x is a bit bigger than 10, the difference is very small. And as you get closer, as you get bigger in x, you get closer and closer to 1. So what your CDF ends up looking like is this graph here. All right. I'm going to calculate the expectation of this distribution because I think it's amusing. So the expectation is given by this expression here. This is in general true for any probability, continuous probability distribution. So we go ahead and we substitute in this piecewise definition. And we're going to handle the bottom limit by just changing it to be 10, right? So what we're doing is we're acknowledging that we integrate from negative infinity up to x equals 10, but that contributes nothing. It contributes the ground sum of 0 to our integral. All right, so now we've got this when we take the that product. So that is 10 log x between 10 and infinity. Now, as we take the limit of the logarithm, that's undefined. So this integral doesn't converge. This integral is undefined. That means, and that's something that can happen with expectations. You don't actually have to have an expectation defined, which means that the variance of x given by, say, this formula, the expectation of x squared minus expectation of x all squared, this is undefined. Which means v itself is also undefined. So your traditional measures of expectation and variance don't work for this particular distribution. And that's just something that can happen with this kind of probability distribution that doesn't decay fast enough. We had to compute probability that x was greater than 15.